Hi students, now the continuation of a state design pattern. In coming to the implementation section, the state design pattern raises a variety of implementation issues. The first one is nothing but who defines the state transitions. Who defines the state transitions. That is the first implementation. In the sense, coming to the state design pattern, here the state design pattern does not specify which participant defines the criteria for state transitions. So here, in the sense, the state pattern does not especially specifically which participant it defines the basic criteria for all the state transactions. Okay, so if based upon the criteria it will be fixed, so then they can be implemented entirely in the context object. So let you know how to treat the state subclasses itself. Whatever we need to specify their successor state, and whenever we need to make the transitions, the state transitions. So finally, this acquire, we need to suppose to adding an interfaces to the context object. So let you treat the state object. First of all, we need to set the context object current state. Depending on its current state explicitly, the context object we need to specify at runtime. Okay, here the decentralizing the transitions logic. In this way, it make very easy to justify or modify. We need to extend the logics, whatever we need to defining the new state subclasses, Here, coming to the disadvantage section of decentralization, it is a disadvantage of decentralization is that one state subclass, if we have some substate subclasses, it will have knowledge of at least one another, so which will introduce the implementation dependencies between the subclasses. Okay, and coming to the second implementation, that is nothing but a table based alternative. Whenever we need to take in C++ programming style, one of the scientists, the Cargill, describe another way to impose the structure on state driven code. Okay, whenever we need to use some tables, we need to map inputs to state transitions. For each state, a table maps every possible input to a succeeding state. In effect, here this approach converts here conditional code, we can say virtual functions, okay, in the case of state design pattern. So it looks like a table lookup format. The main advantage of tables here, you can change the transition criteria just by modifying the data. Instead of we need to changing some program code there are some disadvantages also here. A table lookup is oftenly less effective than a virtual function call. So here we putting some transition logics into a uniform manner. We need to take some tabular format. It makes the transition criteria it should be less explicit, and therefore it should be very harder to understand also. Even it is very usually difficult to add some actions to accompany the state transitions, but the table driven approach, it captures the state objects and their transitions, but it must be perform some operations like arbitrary computations on each transition. So here the main difference between the table driven state mission and the state design pattern, it can be summed up like this. The state pattern model state specific behavior to completely change its behavior depending on its current state. Whereas the table driven approach, it mainly focuses on defining the state transitions, and coming to the third implementation, with creating and destroying state objects. Creating, what we are creating, what we are destroying, the state objects, in the sense, commonly the implementation the implementation trade-off works considering whether first of all we need to create state objects only when they are needed and destroy them thereafter, versus the second key point, we need to creating them ahead of us time and never destroying them. The first choice is to be preferable there. Whenever the state design pattern that will be entered are not known at runtime, and at runtime objects and context object change the state infrequently. Okay, so the approach, whatever the approach come forward, we need to avoid some creating objects that won't be used there. So which is very important in the state object, we need to store a lot of information here. The second approach is need to better understand whenever the state changes occur rapidly, in which case if you want to avoid some destroying states, because they may be needed again and again. Okay, so here the cost are paid once upfront, and there be a destruction cost at all. So the main approach, it might be inconvenient. So because the context object, it must keep some references to all particular states that might be entered here. Okay, this is the main key point of creating and destroying. Whatever we need to create the state objects when they are needed, and we need to destroy them. Okay, so we need to creating them certain time we will take in, and never destroying them the state objects. Commonly, if we have to be implemented the state object preferably, here we need to see at runtime, especially the first choice, the state infrequently we need to change the context object. The second approach, we need to better whenever the state changes rapidly, you want to avoid some destroying state, because they may be needed to you. Okay, and coming to the last implementation, that is nothing but using dynamic inheritance. In the sense, we are changing the behavior for a particular request. It could be accomplished by changing the objects class. Especially at runtime, we need to alter its behavior depending on its state. Okay, but this is not possible in object programming languages. We need to study some exceptions include here the other delegation based languages that provide such mechanisms, and hence we need to support the state design pattern directly here. Okay, so objects in self can delegate that particular operations to other objects. Whatever we need to achieve to form a dynamic inheritance, here we are using some dynamic inheritance. Just we are changing the delegation target at runtime, especially at runtime. Effectively, it should be alter its behavior. It should be changes the inheritance structure also. So here mainly this mechanism let you treat the objects how we can alter their behavior, and amounts to changing their classes. Okay, amounts to changing their classes. And coming to the known uses, what are the real examples of this state design pattern? Okay, here the following examples here gives the C++ code for the TCP connection example. We need to describe in the motivation section. So here this example is simplified to you. Okay. Here we need to study Johnson and G. Wang, what they characterize the state design pattern and its applications to two TCP connection protocols. Most probably we need to take some interactive drawing programs. It provides some tools for performing particular operations by direct manipulations, how we can handle. For example, here we need to choose a line drawing tool. Let's a user click and I am a user click and drag to create a new line. We need to must and should selection some tools. Let the user select shape. Yes, I am selecting some shape. Usually a palette of such tools we need to choose from there. Okay, so the user thinks of this particular activity, we need to pick up a tool and building it. But in reality, whatever the editor's behavior changes with the current tool, whenever a drawing tool is active, we need to create some shapes there. Whenever the selection, we need to select some tool. Whenever the selection tool is active, we select shapes. Okay, we can use some state design pattern. We need to change the editor's behavior depending on the current tool or depending on the current state. Okay, just we can define an abstract tool class. We can define an abstract tool class. Here look at the diagram also I have to be given there. Drawing controller is a class. Okay, tool is a abstract class. Okay, drawing controller is a class. If we have some operations, mouse pressed, process, keyboard, initialize, these are the operations. The current tool here is tool class, from which to define the subclass that implements here tool specific behavior. And here the drawing, here look at this drawing editor. Drawing editor maintains a current tool object and we need to delegate the request to it. So finally we have to be replace this object whenever the user chooses a new tool. Just we have to be taken the behavior of the drawing editor to change accordingly. So finally this technique is used in both the draw function and unit draw, hot draw and unit draw drawing editor frameworks. Just we need to take some templates like this. It allows the clients or users, whatever we need to define some new kinds of tools. It make very easily. In hot draw, the drawing controller class forwards the request to the current tool. Exactly, a current tool object. In unit draw, the corresponding classes are viewers and tool. Here the following, this is the class structure. The following diagrams shows to you the class diagram. The class diagram, what this sketches here, the tool and drawing controller interfaces. Here some subclasses here. Creation tool, selection tool. Here the tool will declare the interface. It will declare the subclass also. Creation tool, selection tool and text tool. Okay, this diagram here if you have to be learn some Coplien and envelope, here it is related to state envelope letter. It is also one of the subclass. Here listen carefully. Coplien envelope letter idiom is related to state design pattern. Envelope letter is a technique. It's one of the technique for changing, for altering an object's class, especially at runtime. So the state design pattern is more specific. The state design pattern is state specific behavior. Mainly it focuses on how to deal with an object, whose behavior changes to alter its behavior depending on its current state. This is the main explanation of noun uses. Coming to the related patterns of a state design pattern, flyweight design pattern, it is very related to state design pattern. What here it explains when and how. When and how the state objects can be shared. Okay, the flyweight design pattern explains when and how state objects can be shared, and the state objects are oftenly we can use it at singleton design pattern. Okay, the state objects are oftenly used singleton design pattern. Here we need to use the flyweight and the singleton. These are the related patterns to state design pattern. Thank you, ma.